Well, hello and welcome to a quick review of the average rate of change. Feel free to pause, rewind, and do what you need to do to make sure we have these down. So first let's take the time to sketch out this function. Now you'll notice the name of my function that I have here is f of x, and I do know that it's a function because it passes the vertical line test. And I'm going to go ahead and label some points on here. Instead of saying this is 1 and 10 maybe, let's call this value a and this value b. Now, again, if this was 1, I would just count up and figure out what my height is corresponding. And basically, I'm going to say this is a, and my function's f of x, so my height is then f of a. What do I get when I plug in a? Same idea here. If this is the b value, its y value is going to have a height of f of b. Now, believe it or not, the average rate of change is nothing mind-blowing. Basically, I want to connect those points A and B, and we'll connect them with what we call a secant line, back from our good old geometry days. And basically, the average rate of change is equal to the slope of the secant line. So let me pause and write that down. And there you have it. That is the whole idea. The average rate of change is just equal to the slope of the secant line. Now, believe it or not, the slope of the secant line is something that you've done since 7th grade. Perhaps you didn't call it a secant line, but you've been doing the slope formula for a long time. So one last time, a secant line goes through 2 points, and the average rate of change is just the slope of that secant line. So you might be thinking in your head, well, the slope between these 2 points is change in y over change in x, and that's exactly what we're going to do. But now I want you to pay close attention to what we call these points. This x value is a comma f of a, and this point is b comma f of b. So instead of saying y2 minus y1, we're going to use our y values. We're going to say f of b minus f of a over b minus a. And let me say that again, it's the same thing as the slope formula, y2 minus y1 over x2 minus x1. This is just a more proper way to say it using the function notation. So, the average rate of change, again, is just the slope of the secant, so f of b minus f of a all over b minus a. And again, this really is just the slope of a secant line, something we've been doing for a long time now. So in my first example, find the average rate of change, and again, I just want you to underline that to yourself and say, okay, all they're saying is find the slope. It's just another way to say slope, average rate of change. Find the slope of this function, f of x equals 3x squared, over the domain negative 2 to 0. Notice, this is not a point. These are both x values, okay? It's not in parentheses, it's not the point negative 2, 0. It's from x equals negative 2 to x equals 0. So, typically we don't sketch this every time, but I'm going to draw a quick sketch just to make sure we're all on the same page. So I'm going to graph 3x squared, which is just a parabola that opens upward at the origin. And I'm going to plot my 2 points. I'm going to start with the easy one. When x is 0, okay, so when x is 0, the corresponding y value is 0, 3 times 0 squared. So that is 1 point, 0, 0. And when x is negative 2, the corresponding y value is 3 times negative 2 squared. Negative 2 squared is 4 times 3 is 12. So that's the point negative 2, 12. And I'm going to plot those points. So I have 0, 0 and negative 2, 12. And again, all I'm doing is finding the slope of that secant line. That's all average rate of change is, slope of the secant line. You can at least guesstimate whether it's positive or negative right off the bat. Clearly, that's a negative slope. And now I'm just going to evaluate that function. So I'm going to say f of b minus f of a all over b minus a. And I'm going to label this, of course, a is my first value, b is my second value. So I'm going to say this is equivalent to f of 0 minus f of negative 2 all over 0 minus negative 2. Okay, so again, it's just the slope formula. Now, I've already actually evaluated those off to the side there. I know f of 0. When I plug 0 in, I got 0. So I've got 0 minus, when I substituted in negative 2, I got 12, all over 0 minus negative 2 is a positive 2, and I get a slope of negative 6. So I already estimated that it was negative, and we've got a negative 6 for our average rate of change. And again, average rate of change is just the slope formula. All right, so let's try another one. Find the average rate of change. Sometimes you'll see me abbreviate that as AROC, average rate of change. F of x equals 3x squared minus 4 over 2x on the closed interval 2 to 6. So again, I'm just stressing to myself that this is not a point. This is my A value and my B value. Now, you clearly don't need to sketch it out every time. Obviously, I was just trying to reiterate that we're just finding the slope of a secant line. So I'm going to say this is f of b minus f of a all over b minus a, which is equal to f of 6 minus f of 2 all over 6 minus 2. And I'm just going to take my time and evaluate. Clearly, the bottom is 4. F of 6, so I've just got it, here's my function f of x. I just got to evaluate f of 6. So 6 squared is 36 times 3 minus 4 gets me a 104 all over 12 minus f of 2. 2 squared is 4 times 3 is 12 minus 4 is 8 all over 4. Okay. Now, again, that might look a little nerve-wracking to you, whatever. We're going to have to be able to clean it up. Nice little complex fraction. I'm going to multiply each piece by 12 and see what I get. That kills that. I've got 104. That's really 2, so minus 24 all over 48. And again, non-calculator. What is it? Oopsie. Gets me, what's that, 80 over 48, and certainly I can clean that up and divide by 2, so that's 40 over 24. I can divide that by 4, so 10 over 6, or 5 over 3. And again, what did we just find? The average rate of change is just the slope of a secant line. Okay, it's the slope between 2 points. All right, let's take a look at the same question with what we're going to call tabular data. And you're going to hear that word frequently throughout the year. And all tabular means is that we're given data in the form of a table. All right, so nothing mind-blowing. Tabular data gives us the form of a table. You're going to answer the same question. Find the average rate of change. All right, and you should be highlighting this. We're going to do a lot of highlighting this year. Average rate of change, again, is just in disguise, is saying find the slope of the secant line. And again, a secant line is a line between 2 points. Find the slope between 2 points. Now, you don't have to guess at what they are. They're going to tell you. And they're telling you between 0 and 15. Now, again, they're not 0 and 15. It's from x or t equals 0 to t equals 15. So basically, because you see that t, you go to the line with the t, you find the 0, and there's a point. You don't have to do much math. The t value is 0, the y value is 90. You do the same with 15. Again, that's like my x value and my y value. So because this function was named p of t, I'm going to use p in my formula. And I'm going to say the average rate of change equals p of 15 minus p of 0 all over 15 minus 0. Okay, so it's f of b, one last time, f of b minus f of a over b minus a. And if I just read my table, p of 15, so when I plug 15 into p, I get 50. Minus, when I plug 0 into p, I get 90. All over 15 minus 0. Now, the other thing I want to pay close attention to before I clean this up is the units. The 50 and 90, if I read the table, are in degrees Celsius. Divided by the 15 and 0, the units are minutes. And again, I'm not guessing at this, I'm just reading the table. It will tell you everything you need to know. And as I clean that up, that gives me negative 40 all over 15 degrees Celsius per minute. And that's all we're looking for. average rate of change. Well, that takes us to the end of our average rate of change video. So keep in mind, average rate of change is just the slope of the secant line, f of b minus f of a, all over b minus a. So again, just like always, if you have any questions, you know how to get a hold of me, and I look forward to your last assignment and seeing you that first day of school. Enjoy the rest of summer.